Okay, let's get the recording started. We're going to rewind just like one slide or two slides because I finished that kind of in a hurry last time. So I wanted to give an opportunity for anybody who had a question to jump in and ask their question, okay? So this is the last thing that we covered during the last lecture, the stack of integer. So I explained what was the idea behind a stack of integer. We can have a stack of integer, a stack of double, a stack of float, any data type, okay? You can even have a stack of stack of stack. I don't remember ever seeing that anywhere, but theoretically possible, okay? Practically, maybe the utility is discussable, but, you know. So the only trick we had actually in this implementation is on this slide. The next slide that I ask you to take a look at, this one, doesn't have really much on it. It has 3 one-liner methods, okay? Pop, which is going to just return an element that is the last element in the stack, so the topmost element, and decrement the size. So the only thing I have to say about this one is when I say we remove an element from the stack, we actually do not do anything to remove it. All we say is, you know what? The size told me that I had 5 elements. Now the size tells me that I have 4 elements. And that's enough to actually remove the element from the stack. Okay? Why? Because the next time you add a new element, you're going to look at the current size, and the current size is 4. So you're going to go ahead and add something at index 4, which is going to override what was there before. Okay? So we do pop actually the element. It's just that there's nothing special to do about it besides managing the index size. Okay? The peak, well, we return element index size -1. So difference between size -1 and minus size is one of them modifies the value of size, the other one doesn't. So we are still using the same logic of accessing the last element at index size -1, but in one case we do pop the element, in the other case we do not. And empty is simply checking if the size is 0. So those 3 methods here, they are not the problem. This one is not that complicated, but we are going to use it at least in 3 examples before the next exam, okay? So it would be wise to assume that as an exam you might have something similar to do. What we are doing here is, first, if the size is not greater or equal to elements.length, so we just add an element at the size index, and that's it. Okay, there's nothing to think about there. If your array is infinite, has 1,000,000 slots into it, and you want to add the second element, you just look at the size index. It should be 1. That's the second element in the array. You add there, and then you increment size. Okay, so that's the easy path through this code. If this condition is true for, well, size keeps track, like I mentioned already, of the number of actual elements inside the array, inside our stack, okay? So I compare it to elements.length. Element.length is another way for us to get the capacity of our stack. The capacity of the stack, remember, it's how many elements maximum it can hold. Well, we decided to create an arbitrary large array at the beginning, let's say 100 elements, okay? And we said, okay, this is our capacity. So every time I look at the array and I say the name of the array .length, so elements.length, I'm getting, as an answer, the capacity of the current array. So what I'm saying here is that if I exceed the capacity of the current array, or I'm already, to be more exact, if I'm already at capacity, okay, I have that many elements, I have that many slots, I'm full, then I'm going to replace that array. And that's what we do in those 3 lines, okay? We replace the array that is referred to by the attribute element inside the object. We replace it by a brand new shiny array that is just larger. How much larger? Twice the size of the current one. So that's where we create it. Temp is going to be an array of int. We declared it here, okay? So we create new int, square brackets, elements.length. So again, the current capacity times 2. So we double the capacity. Now that we have this new array, what do we do with it? We have to copy every bit of data from the old array into the new array. Okay, our goal is to, after those 3 lines, we forget completely about the old array. So we're not going to keep it around, to save the data to back it up. What we are going to do is we're going to use system.arrayCopy, and that's completely new. This is the first time we introduce it in this slide and in this chapter for the reading assignment. This is one of those little methods that is, one, misspelled, okay? You know that Java loves the camel case notation, lowercase for the first word and uppercase for the second word, first letter, etc. This obviously is not following the convention, which is weird because it's a method from the JDK. I was told this is due to legacy issues. They didn't have the convention when they started. They introduced this method, and nobody wanted to go back and change the name of the method afterward. So take it with a grain of salt. This is just as far as I could find out on why this irregularity exists in the JDK. But this little method is, as the name implies, a method that is going to allow us in one line to copy the content, the data from one array to another array that is large enough to accommodate it. Okay? So not too bad. If we didn't want to use this, we would have to do what? We would have to do a for loop. Okay? We would have to write our own for loop that say, for pretty much every index in the old array, take the element of that index, copy it as the same index in the new array, keep doing that, and you are going to fill half of the new array, and then you're good to go. Okay? So we could replace that line with a for loop. No problem there. This is even easier. It's easier once you get used to the wonky syntax. It's a little bit wonky because it does more than just what we need right now. What we need right now is copy everything from one array of size 10 into the first 10 slot of an array of size 20. Okay? But you can do much more with this method. For example, here, the first argument of the method is a source array, where the data comes from. And what you have here is the destination array, where the data is going to go. So you could say, I'm taking data from this array into that array. But you could even say things such as, I'm taking data from this array here, starting at index 0, and I'm copying it on the same array, starting at index 100. So the sky is the limit, right? It's a very, very flexible method. You can do all sorts of things. So that means that if we wanted to do stuff like that, well, we elucidated this parameter and this parameter, but we need a way to specify indexes, Where do I start the copy? Well, the second parameter, oops, didn't mean to do that. The second parameter here is with reference to the first array, the source array. And it tells me where the copy is going to start. So here's my source array. I start at index 0. This is why I have a 0 here. I start at the beginning of the array with the first element. If I wanted to copy the second half of an array, I would start at, in this case, elements.length divided by 2. Okay? So I really can position pretty much a reading head wherever I want in an array to say, I'm going to start reading element and copying them from there. And then the destination, same thing, except that the number that you specify after the name of the destination array is actually the index at which you want to start copying into that array. Okay? So here, like I said, it's a very basic case. We want to copy everything from that guy into that guy. So we start at index 0, the beginning. We start at index 0, and we go 0, 1, 2, 3, 4, up to whatever number of element we have. Okay? But again, if we were doing that copy, in the same array, we could say something like system.arrayCopy, my data, let's say that this is a reference to my array, index 0, so start copying at index 0 my data, and then as target, as destination, my data as well, but starting at index 100. So what I would do is I have a huge array. I would say 0 is here, 100 is here, copy, 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 copy. I could make a duplicate like that of like the first half into the second half, for example, of an array. So it's very flexible, okay? And then we are missing one thing here to be able to wrap this up with a nice little bow. We need to be able to say how many elements we are going to copy, right? That's the last parameter. The fifth parameter is, okay, you told me where to start here, you told me where to start writing here. So I read here, I write here, but how many do you want? And in our case, again, we're going to say elements.length because we want to copy everything in the array elements into the new array temp. Okay? And when we're done, what do we have? Well, we have the attribute elements that is still referring to the good old array. Okay? And then we have this local variable temp that is referring to a brand new array. If we quit here, nothing really happened, nothing useful happened. Sure, I created a new array. Sure, it's twice as big, and half of the data, is actually the old array. I did my job, but I didn't switch around. I didn't tell my object from now on, your array element, forget about it. This is your new array element. And this is what I do on the last step. Okay? All right, so I wanted to take the time, to go over this without like rushing. Any question? You guys are okay with this code? You're solid? So we are going to use it a lot. So even if you're a little flaky, still a little bit flaky, don't worry. We are going to practice that. You're going to be okay with it by the time the next exam comes. All right, so talking about the next exam. With this stack of integer example, technically, sorry, I choke on my own lies. Technically, you have enough for the next exam. I say it's a lie because we're going to still practice a little bit, okay? We're going to have at least 2 examples and 1 live coding example. So right now we are headed towards the next session to be like almost entirely live coding, okay? Kind of like what we did last time for IE1, just to prepare you for IE2, okay? And IE2 is coming next week, sometime next week, probably Friday, okay? I haven't set the date yet, but you can expect, 90% chance that this is going to be what happens. But the bottom line is that if we want to be like strict and technical, if we were in a rush, we covered actually all the concepts you need for IE2. Now we are going to add additional concepts, okay? But these are going to be more important for IE3. Always the idea of not, rushing into the exam, the last thing that we covered. So before we jump into those new concepts, one more example that is going to be similar to this one, and I'm going to have a part of that example that is left as an exercise, actually 2 parts. So if you want to start getting practice, again, start as soon as possible, and this example is going to be good. So we are going to have a course and a test course class. So by now you should be used to the structure, okay? I try to use the same structure on purpose. One class that is my primary class, the one I want to deliver, give maybe to other programmer, reuse in another project. And another class that is simply pretty much the test class, for that primary class, where I make a few objects, call all the method, etc. So I had a few questions about, what are exactly the tests that we need to write. For example, for IE1, what kind of test did you expect it to write? The same kind of test that I wrote for you in live coding, create an object. Oh, you have 3 different constructors? Then create an object 3 different ways. The goal is, if you write 5 constructors and 20 methods, the minimum you can do to test your own code is use at least 1 time each of the constructor and use at least 1 time each of the method. Okay? And in the points that we gave you, in IE1, that was the first point. The first point is, hey, you try to make everything work. Call it at least 1 time. Okay? The second point was maybe some methods, the instruction tell you, by the way, the parameter should be between 0 and 10, otherwise I do nothing. So these are like added constraints, right? So you should call the method, that kind of method, you should call it once, with the right parameters. And then you should try to call it maybe another time, giving it a negative value, just to see if it's able to ignore negative values. Then maybe I give it a value that is bigger than 10, just to see if it can ignore, the range of values that are not supposed to be taken into consideration, okay? And with that, you have like 2/3 of the point. The last third of the point was, hey, when I run your code, did you take care of putting some system.out.println that explained, what you were doing so that somebody can inspect the output and have an idea whether it's working or not? And that's it, okay? So this is the bare minimum that I really encourage you to do every time you work on one of those practice exercises, especially the one that I give right before the exam. Do this. Come up with your own test, okay? We're not going to be super picky about the kind of test that you write, but having the reflex of testing your code as you write it, this is gold, okay? This is going to make your life so much easier. So give it a shot, okay? Here, we are going to have this test course class, and we are going to have the course class. So let's take a look at the UML diagram for the course class. So 3 attributes, okay? 3 attributes, each of them are private. Again, that's going to become a routine. It's really rare in this class that I actually let an attribute public, that I leave an attribute public, okay? I tend to lock down all of my attributes so that nobody can mess around with them. It's a case of in doubt, be safe, okay? So here we have a course name, which is a string, no problem. We have an array of string that is going to be the students enrolled in that class, okay? So I'm going to keep track of who is enrolled in my class, but each student is modeled just as a string object. I could have done something a little fancier, right? Have a student class inside of which there is a first name, last name, social security number, whatever, U number, whatever you want to think of, you could model, in a student object, okay? Here, I'm going a little bit simpler. Student is just a string that represents his or her name, okay? All right, and then number of student, that's going to be an int. That's going to be how many students are actually in that array. So that's starting to ring a bell, right? We have this capacity in the array. Then we have maybe a size, but the size here is called number of students instead of being called size. Again, that pattern you're going to see a lot, especially in data structure, okay? So it's a good idea to get used to it right now. What else do we have in that class? We have a constructor, which is public. Most constructors are. So the constructor takes a course name as a string. So no surprise there. We're going to assign that string to the course name attribute, okay? We can already tell that much just by looking at it. Then we have an accessor for that attribute course name, get course name. That one is not going to be a problem to implement either. Then we have stuff that's a little bit more interesting. Add student. Give me a student as a string, a student name actually as a string. I'll add it to my students attribute array. Okay. Drop student. Give me the name of a student. I will make sure I remove that string from my array. So that one is going to have us do a little bit more convolutions there. Okay. Get students. Give me the list of all the students. So give me the reference to your array. And get number of student, that one is trivial, just return to me the value of the attribute number of student. So we are going to start with the code that with the code that tests actually the primary class. This is actually something that is done in practice for real world project, okay? It's called test-driven development. I don't know if I ever took the time actually to explain that acronym and that little joke on the side there. But if you are curious about test-driven development, it's a good use of your time. If you're going to do any sort of development in your career, read a little bit about TDD, test-driven development. It's very simple to understand. That just means you should write your test first. In this course, I am not going to force you to write your test first. I'm not going to force you to write your test last, because I'm not trying to teach you a specific software engineering technique, right? So whatever you are comfortable with, I'm happy with it, okay, as long as it gets you the results. But I will mention that some people systematically write their test before to write actually the primary, what I would call the primary code. Why? Because that forces them to think about, hey, how are other programmers going to use my code? What are the requirements telling me about how I should be using my own code, right? So you start by the final result. For example, I want to be able to create an object like this, a new course data structure. Then I want to be able to create an object like this, which is exactly the same requirement, okay? I specify a string, and I get a course with that string. If I write this first in my test class, and then I say, okay, let me find out what is the minimum amount of code I can produce to just satisfy those tests, make it so that those kind of requests work, that's test-driven development. The opposite of that, write your code, then worry about testing it later. My suggestion, do a little bit of both. Go back and forth, okay? Write a test, write the code that makes that test work, then go back and forth, write some more tests, write some more code, and like this, okay? So we're not going to do it formally one way or the other, but I really encourage you to experiment with, when is it a good time for me to write tests, and depending on how your mind is thinking about those problems, you will find a comfort zone there, and use that comfort zone to get some good results in this class, okay? So after we have created two courses, we just add a bunch of students to the first course. We add a bunch of students to the second course, okay? And then we're going to say, okay, here's the number of students in the first class. We are going to ask the first course to get us the array of all the students that are enrolled in it. So this is this line, and I don't think I have my pointer. I don't. So there we go. This is this line right here, okay? I have a local variable also called student, but it's just a coincidence. And I ask course1.getStudents. And now that I have this array of string, I can iterate over every single string in that array. So this is a counter control loop. And I display the name of every student separated by a comma and a space on the same line. Then go to the next line and then display the number of students that are in course 2. So I'm just playing around. Okay, create one course, create another course, put some student in, display the list of students to make sure that these are the students that I put in actually, and stuff like that. Okay, it displays the number of students in both courses to make sure that the right number of students is there. And that's it for my test. This is it for my main method, for my test class. I'm just going to do that for now. Now let's take a look at the course.java file and the course class. So this is the one that I'm supposed to deliver, right? So attributes, same level of difficulty than IE1. IE2 is going to have the same level of difficulty than IE1, roughly speaking. But for things like attribute, definitely. I tell you, declare an attribute of this type with this name. This type, this name, and I tell you somewhere in the instruction whether I want them private, public, or default visibility. There is nothing that should go wrong there, okay? Which means if you encounter a problem, okay, don't feel bad and hide in a corner, just come and see me and let's iron it out, because I can guarantee you that everybody in this class is going to be able to do that in no time, okay? So if you still have problems, just come and talk to me, okay? So here we have our 3 attributes. Pretty much what the UML diagram told me to do. I'm just following here the directions I was given. And then I have my constructor that takes a string course name. So I have to use a des dot notation again, because parameter name is the same as the attribute name. So des dot course name equals course name. Do I have to use a des dot notation here for students? No. No, because there's nothing else called students right now in the scope. Okay, there's no parameter called students, there's no local variable called students. So when I say students, Java understand that because I'm in a method of the class course, I'm talking about the attribute of the class course named students. So this is a little bit like over the top, a little bit pedantic, right? Des.student. So is des.number of student for the same reason. So what do I create here? I create an array pretty much of capacity 100. So by default, I'll be able to accommodate 100 student names, okay? And I say the number of students, so the size right now is 0 because I don't have anything. The course is empty. I just create the course and initialize it, get it ready to go, okay? All right, a few things that we can do to improve this code. So the first one I already blurted out, this. This here is unnecessary. So we could refactor. It's not going to be a big deal in this course, right? But as you go to the next programming course and so on and so forth, people are going to expect you more and more to pay attention to those kind of things, okay? So just to make sure that you understand when it's necessary, when it's not necessary. So this is the first thing we can fix in this specific code. Do you see anything else that is kind of a little wonky? We're not talking about bugs. We're talking about, what people would refer to nowadays as code smells. They're part of my code that really are not that clean. Anything jumps out? What do you guys think of that 100? Yeah, go ahead. Do I need the string first name? Was that your remark? No, I don't. Now, when you create an array, you don't have to put the parentheses. You put square brackets, the size. Yeah?
Why do we have an array size of 100?
Are completely arbitrary. Somebody told me at some point, I want that size, or even worse, nobody told me anything, and I just made that up. So that's actually a good remark too. Where did that come from? Definitely not the requirement that I had on the previous slide. So you have to always know where those kind of constraints come from, or else you bounce it back to your client. You say, hey, you didn't tell me what kind of capacity you want. Is 100 okay as an initial capacity? Okay, but I could have 100. In the next example, I'm going to use 1 just to save some memory. Okay, so that's a good point. But since we're talking about that 100, let's stay focused on the 100. The second problem with that 100 is that it's written 100, which is the commonly accepted way to write 100. I would agree to that, okay? Unfortunately, if my application was, let's say, 100,000 lines of code, what are the chances that I'm going to encounter the number 100, at different location in my code? Well, pretty high. What if it's a million lines of code? Even higher. So what I'm trying to tell you here is that I have this magical constant, okay? And we did establish that it's magical because there is no grounding for us to choose 100 instead of 50. but I write it by hard coding it inside my code. So maybe I'm going to need it here, where I create the array, and let's say that I'm sloppy and I write a few constructors and I don't chain my constructors, okay? So now, maybe I'm going to have a few constructors that are each going to create a base array of capacity 100. Maybe at some point else, somewhere else in the class code, I'm going to use again the capacity. Even worse, maybe that capacity is used outside of my class course. And then as my code grows, one day somebody comes and say, you know, a capacity of 100, this is really wasteful. We're trying to work on some embedded software here, whatever the constraint is. I don't want you to keep wasting memory like that for nothing. So I want you to reduce that to 10. So now you are doing Control S through everything, every piece of code that you have, looking for the value 100. And every time you find one, you have to read the code around and figure out, is that 100 meaning the capacity, or is that 100 meaning something else? Okay? To avoid that, constant. Put that 100 as a constant, put it as a final static attribute in your class called, you know, the capacity or initial capacity, like we did last lecture, and that's going to actually save you a lot of trouble when you have to maintain your code. Okay? Getters and setters, that's profoundly, at this point, that should get profoundly boring, okay, because it's just return and change. It's so boring, as a matter of fact, that some language actually do that for you. They just have a notation where you say, I declare an attribute, and you add a little bit of syntax, and then the language say, hi, Captain, I will generate the getter and setters for you, which is cool, okay? It's especially cool when your getter and setters do nothing useful, like does one. If your setter, for example, is implementing some policy to double check that the value you're trying to set is acceptable, then forget it. It's worth your time, okay? But these are examples of, you know, why people say that Java is really verbose. Java forces a programmer to write a lot of code to do a few things. Okay, that would be the kind of code. Is this class immutable? That came out of nowhere, I know. There was no transition there. I see some no there going on. How many people think that this class is not mutable? This is a trick, okay? Not mutable, not immutable. Watch out for that. So this class is not mutable. I cannot mutate it. Okay. What about the other answer? Everybody? Yeah? No, not even. Okay, so you guys are really thinking that there's a trap there. No. This class, what's the problem? Why is it not immutable? Why is it that I can actually mutate this class, that I can change it despite all of those attributes being private? Any idea?
Because when you run your tests, it changes the value.
Actually, my tests do not change the value yet, but I could. That's exactly the point, okay? In my main method, I could write my test so that I alter the content, you know, of an object of class course. I haven't done it yet, but yes, I could do it. That's the problem. So where does this problem come from? What did I do in the code for this class that makes it actually not immutable, so very much mutable, modifiable, you know, without the consent of the author? So the class is public, but I was halfway there, right? I made my class public, which is okay. This is not the problem. But I made all my attribute private because I didn't want people to be able to mess around with my attribute. But yet I failed. So it's not because the class is public. That is okay. That just means people can create object of my class, you know, elsewhere, which I want to allow. But I don't want them to modify the content, the attribute inside. Which part of the boring code on this slide is responsible for breaking the immutability of my class? What do you guys think? So, the array, yes. Yep. Because I have a getter on my entire array, right? So I return to you a reference on an object of class array of string, which is called students, okay? Once you have that reference, you can do whatever you want on that array. You can go inside index 5 in that array, put a null there, which is pretty much you just, you know, removed one of my students from the list without me even knowing it. You can do all sorts of things. So this is kind of a leak. You could call that a sort of security leak here, okay? I wanted to preserve the integrity of every one of my object of class course. Make sure that they were always consistent. I wrote the getter, I wrote the setters. The getter and the setters, if you use them, you're never going to break anything. But then somebody can say, give me the array and I'll tinker with it directly, okay? Then you bypass completely all the safety measures that I have. So watch out for this. If I was returning a string, a single string, no problem, strings are immutable. If I was returning a reference to an object of class integer, uppercase I, no problem, integer objects are immutable. I return a reference to an array, red flag. That means somebody can modify the contents of that array with that reference, okay? And it does matter. It matters insofar that, as we discussed actually last time, principle of least privilege, right? You should not write code that allows another programmer to do on an object of your class something that you did not want them to do explicitly. If you didn't wake up that morning thinking, I want those other programmers in my team to be able to create an object, then get reference to the student array and maybe erase a few students from there. If you are not okay with that, then you should protect against it. Bottom line, okay? All right, so even that boring code, even that trivial code, etc., watch out. Yes, it is, after a while, we don't even pay attention to that code. We just write it, etc. But there's still potential for bugs, so just be aware of that. When it comes to immutability, always double check all your getters, setters, and see if there is a way to work around your logic, okay? What about the add student? So here's a very naive version of add student. You want to add a student whose name is the parameter you gave me. So I go to the index number of students inside my array student. So I use the same logic that we did in the previous stack of integer example, okay? The size tells me where there is an empty slot. Well, in this case, size is number of student. And I assign to that slot the string that you gave me, and then I say number of student plus plus, increment by 1. Break it. What's wrong with this code? How do we abuse this code? We can abuse it verbally, call it names and stuff, but I mean something more technical.
Make it an array of answers.
Make it an array? Make what an array? So I'm not going to change, the type of the parameter. I see where you're going there, but I'm not going to change the type of parameter. I'm just pretty much saying if I do not change this code right now, what could possibly go wrong here?
If there's not room in the array for another student.
Bingo. That's okay. That's how you need to think, not only from I would say a security perspective. You guys know you have to think like that, okay? But even when you are writing code, always code defensively. The best way to code defensively is to think, what can go wrong with my code? So every time you write a line of code, you ask yourself, how can I break it? How can I abuse it? How can I make it do things that I really don't want it to be able to do? Okay? And in this case, that code in and by itself looks good. But if I keep calling it on my array, okay, my array that has a capacity of 100, I keep calling, when I have called it 100 times, what's going to happen? There's going to be an exception. My application is going to actually crash because I went over the capacity of the array. So that ties in also into testing. What would you consider a good test for this class? Adding 1 student? Adding 2 students? 3 students? 4, 5? Maybe we jump to 9 because it's a nice number. I don't know. What matters is what? Being able to add 1 student. Maybe being able to add a few more, just to make sure it was not a fluke and we don't always add the student at the first position and we messed up somehow our indexes. And try to add the maximum number of students. Test your limit. When is this code going to break? So that logic of when is this code that I'm writing going to break helps you come up with tests, helps you come up with tests informally and both informally and formally, okay? And allows you to make sure that when you deliver the code, well, at least you were not able to break it. Now your client is going to press a key and immediately everything is going to break during the demo with the stakeholders, etc. But that's Murphy law. Okay, we cannot control that. But at least you did your best before to deliver some code or have it graded, for example, to break it yourself. And the more you try, the more solid your code is going to be when you deliver it. Okay, so we can break this code. We should check that number of students is lesser than 100. But then lesser than 100, this is again what I was talking about last slide. You know, where is that 100 coming from? And why do I have 100 written here? Use a constant. Okay, use a constant, something like that. A final, static attribute, for example, in your class. That will be a lot better. Or, if you don't want to introduce a final static attribute that is just the capacity, how else could I check the capacity of my array? Just by looking at its length. Okay? Any of those solutions, either of those solutions would be better than what I have right now. All right, and that's it. So with those two examples, and the second example needs, by the way, needs improvement. So here we should definitely improve to protect this code, okay? And here, as a drop student, you must learn to love those kind of things. Left as an exercise. So that doesn't necessarily mean it's trivial. That means it's good practice, okay? So between now and next lecture, what I would really recommend is take this code here that is really flunky and improve it. You can download the code from the textbook. There is a website, okay? Download the code example from the textbook. Don't retype everything. And then try to fix it. Put it up to the standard of the previous example real quick, just to make sure that all of those mechanisms are super clear in your mind, okay? And if you bump into a problem, it's not graded. So Piazza, study group, office hours, whatever works, okay? All right, now we're going to talk about those few concepts that we need to also work in this module. So the first one we're going to talk about is the concept of a wrapper class. Here's what we are dealing with. So we have a bunch of primitive data types in Java. And this is this whole section here, this whole concept of wrapper class, you have to understand that it is relevant only because of the way Java is structured. If Java didn't have primitive data type, we would not be bothering about talking about those wrapper classes, okay? Some language like Ruby, Python, everything is an object, okay? So everything is a reference to an object. We don't have an int. We don't have an int variable. We don't have a long variable, a double variable, okay? So for those language, there's no need for wrapper classes. For languages like Java that have the distinction between reference data type and primitive data type, there are times where we wish we had objects. Sure, primitive data type were introduced so that things can go faster. It's easier to manipulate an int value, like 0, 1, 2, 3, as a counter of a loop, than to manipulate a reference to an object that represents an integer. And then every time you want to access that value, you have to follow the reference, which costs you, actually, in terms of CPU cycle. And you have maybe to call getter, setter methods, stuff like that. All of that is expensive. Object-oriented programming can actually lead to bloat in your code, okay? Very, very easily. So if everything is an object, you have to go through constructors, getter, setter, etc. The garbage collector needs to juggle, every time you discard an integer value. That's why we have primitive data type in Java, because there are things for which we really need just an int, or a char, or a boolean, and we don't need that to be an object. We don't need that level of complexity. But then again, what happened over the first few decades of Java's existence is that people said, well, all of those algorithms that you guys are going to learn in data structure, okay? All of those things you are going to learn in data structure. Well, I learned them, you're going to learn them, your kids will learn them probably. But when it comes to actually I have a job and I need to do something with data structure, very few people implement actually those data structure. That's something that we do as students when we're learning about them, just to really understand what's going on inside, right? But then after that, we're not going to reinvent the wheel every new decade, right? So that means that most modern language, like the vast majority, I cannot think of a counterexample to be honest, the vast majority of modern language, they come with a standard library that is quite extensive. You want a stack? I got you covered. You want a queue, a priority queue? I got you covered. What about tree, graphs? All of those data structures are already implemented. But what happened with Java is that when they started implementing those data structures, they used object-oriented programming principle because OOP principles are really good for implementing libraries that offer data structures. And then what? And then they realize, oh, but wait, now we created an entire little world, where people can very easily reuse our code because it's object-oriented. And then there is this guy there that wants to do a tree that contains just int value. And unfortunately, int is a primitive data type, and we wrote all of this code in the JDK to work exclusively with object. Which means that you want a stack of students objects? Sure. You want a stack of, temperature object? Sure. Do you want a stack of int? That's not a class. Int is not a class. I cannot have object of class int. So it doesn't fit in my framework. I have those primitive data types that are super efficient to use, and I have this framework that is super convenient for people not to have to rewrite, basic code on data structure, and they don't talk to one another. So this is that part that we're talking about right now, that glue between the two. How do I fit my primitive data types into the JDK that only expects to manipulate object? Well, the solution to that is, even though, we were saying it's not a good idea in some cases, to have an entire object to represent one int value, one miserable int value. Well, that's exactly what we're going to do when we have to. So we have a class called integer with an uppercase I. The only purpose of the class integer is to pretty much create an object that is wrapped around an int value. At the core of that object, you have an attribute of type int, and that's the goal. The whole goal in life of that object is to wrap around it and allow you to use that int wherever an object would be expected. If you have to put an object in a stack or in a list or in a queue, then it's going to be an integer object. If you are only manipulating int values, you're going to have to convert those int values to integer object before you add them to that data structure. And we are going to see that Java tries really its best to make it as convenient as possible, but this is a little bit of overhead, this is a little bit of burden, okay? So for each of the primitive data types, Boolean, char, short, byte, integer, long, float, and double, we have a corresponding class in the JDK that is spelled, pretty much most of the time like the primitive data type, except character instead of char and integer instead of int, okay? And this is the wrapper class for that primitive data type. That's it, okay? So all of those classes are provided to us. Very nice little feature. All of those classes are actually immutable, okay? So just like string, and this has been a trend in Java. Some of you were using the date class not long ago, and you got a weird compilation error that say, hey, date is deprecated and stuff like that. So the trend in Java is to make more and more classes immutable, because that allows us to adopt a more functional style of programming, which allows us to avoid bugs. Okay, pretty much. That's the headline you need to remember. Immutable is good because it allows to avoid bugs. So all of those classes, generally you never have to worry about them. You create an integer object. There's no way somebody can sneak through the back door and modify it without you knowing. Okay, if you want to increment that integer object by 1, you're going to have to create a new integer object that is that value plus 1. And that's going to become heavy. Okay, because now we are talking about like an index for a loop, int I equals 0, I lesser than elements.length I plus plus. That I plus plus was super efficient because I was an int. If I want to do the same thing with an integer, then I have to create an integer object that contains 0. And then when I want to increment it, I need to create an integer object that represents 1. And when I want to go to 2, I need to create an integer object that represents 2. So that's the theory. And the theory is that if we did it like that, Java would crawl even more than it does. Okay, so there are optimizations. There are optimizations where, I don't remember, the first n integer, for example, are already created and cached in memory so that you don't have to go through the creation and destruction of those, basic objects when you are using those small values. But yeah, there is an overhead. It's complicated. The Java compiler has to do more work. The Java virtual machine has to do more work just to do this trade-off between efficiency of the primitive data types and convenience of full-blown object. So we are going to take a look at the UML diagram for two of those classes. We are just going to look, like very, very briefly at what those classes have to offer. Why only those two? Because they are very similar, and that's the gist of the idea I want to convey here. Those classes are all going to feature pretty much the same methods, the same constructors, the same style of constructor, and so on and so forth. So we're just going to look at those two, point out, how similar they are, and then move on. So we have a bunch of attributes. We have a bunch of constructors. So two constructors here on the left, two constructors on the right. The first constructor takes an int value. Well, that's for the class integer. The second constructor takes a double value. That's for the class double. So that makes sense, right? And then both of those classes accept actually also a string as a parameter to their constructor. So if you were to pass me a string that contains the value 23, the character 2 and 3, I would be able to create an integer object from that. If you give me a string that contains 23.9, I can create a double object out of that. And then a lot of methods that are there to do conversions. So since we have to have a class of type integer, we might as well put into it everything that we need to manipulate integer and convert them to different value. So let's take a look segment by segment to this table here. So the first thing that we have the very first thing that we have actually is a private value of type int. That's for the class integer. For the class double, I would have a private value of class of type double. Okay? And then we have those things here. They are underlined, so they are going to be static. They are in uppercase, so they are going to be final. So these are static final attributes, aka constant, class constants, okay? One that says max value, one that says mean value. So if you are talking about max value, the meaning is very simple. This is the biggest possible value that an integer can have. So since the integer wraps around an int, this is the biggest possible value an int variable can also have, okay? Easy. What about the mean value? Well, it doesn't take a Nobel Prize to make the hypothesis that this is going to be the smallest value, except that the concept of smallest value has a different meaning when you talk about integer, like int, long, stuff like that, and when you talk about floating point number, like float and double. When you talk about integer, the concept of the minimal value is exactly what you're thinking about. It's the smallest possible value that I can represent with an int. So it's going to be minus, let's say, I don't remember if they are 32-bit or whatever, but minus 32,000, something like that, maybe? All right. So that's intuitive. And then what about the float and double? Well, for the float and double, it's the smallest positive value. So it's not actually the smallest value that we can represent. It's the smallest positive value. What is the smallest fraction of a number that you can represent with a float? And what is the smallest fraction of a number you can represent with a double? Okay? So if we were to just display those constants, so here's a little piece of code, just a class with a main method, and inside that main method, system.out.println, and I'm going to display integer.maxValue, integer.meanValue, and then I'm going to do the same for float and double. Okay? So float, actually, I'm going to display only mean value, and double max value. And I get those results. So this result and that result, yes, again, intuitive. So the largest and the smallest, which is going to be by necessity negative, int value that can be stored on this Java virtual machine are displayed here on the screen. And then this is the smallest fraction of a number that you can represent with a float. So 1.4 exponent minus 45. That's pretty small, okay? If we were looking at the double, it would be even smaller. And then for the max, well, there we go, 1.79 exponent 308, okay? But by now you should have a little bit of an intuition about floating point number. At the very least, you should have the intuition that beware of the floating point numbers. Yes, they can represent extremely large and extremely small values, but they do that sometimes at the cost of precision. Okay, they are rounding up and down, that happen all the time. So yeah, floating point numbers are not perfect. But once you know that, you save yourself already a lot of trouble. What else do we have? So this is just a constant, okay? The attribute, I didn't mention really anything special. It's in there, it's private, it's hidden away. Those two constants are public, so yes, we can access them like we did in the previous example. And then we have here, for the class, we're still looking at the class integer, right? We have here two constructors. And you can expect the class double, the class float, the class byte, etc., to have also two constructors similarly minded, okay? So the first one takes an int, which is a value that we wrap around. The second one takes a string. No problem. I already explained pretty much what the ID is there. The one thing I would like to draw your attention to is we don't have any no-arg constructor, which actually makes sense. It makes sense because if you tell me I want to create an object that represents an integer, my first question to you will be, sure, what value? If you don't know the value yet, you don't need an object to represent a non-value, okay? So every time you create an object of class integer, double, float, etc., any of those wrapper class, you know already what is the value you want inside. Either you have it as a primitive data type, which is the first kind of constructor, or you have it as a string, which is the second kind of constructor. You just pass it to me, and I will construct an object that wraps around that specific value. The next block of method, and we're not going to go into each of them, I just want to try to give you an overall idea of what's there, what's available, okay? The next block of method for any of those wrapper class, or at least a numerical one, right, is going to be conversion method. So we know that the wrapper class contains at its core an int. This is the attribute here, value of type int private, okay? So at its core, it contains an int value. What if I want to obtain a byte version, a byte conversion of that int value? I call the reference to that object dot and the method byte value parentheses parentheses. Okay. And same thing for if I want to convert it to a short, an int. An int there's not going to be much to do, okay, because it's already an int. But a long, a float, a double, etc. So all of the typecasting that you learn in COP2513, no matter the language, okay, whether it was Python, Java, whatever, doesn't matter. But all of that, those operations that are meant to convert, for example, an int like 23 into its representation as a floating point number, like 23.0, right? All those differences here, you can access that here. You can have conversion done for you explicitly when you have an object of class integer by calling the right method, okay? So is it super, is it necessary? Is it super useful? Technically, we were doing all of that without objects. So no, we could do that just with primitive data type. But the idea is everything that you can do with a primitive data type, it would be nice to have it available as well when you use those wrapper classes. Why? Because otherwise, we would even more often go back and forth. I would say, okay, I need a primitive value. Here it is. I use it for a while. Then I say, I want to put that value in a data structure. All right, okay, let me wrap it in an integer object. Then I use it in my data structure. Then I say, I want to perform some operation like typecasting into a double and int, for example. Oh, well, wait a minute. I'm going to have to get that value out of the integer object, then convert it, using the old techniques from COP2513 into a double, and then put that into a double object and re-inject that into a... Okay, that gets old, okay? So again, the deal is that in theory, this can be arbitrarily heavy, okay? In practice, Java tries to simplify a little bit things for us, so those methods are an attempt to allow for some easier workflow, pretty much. So we have some interesting jargon there on the right side, okay? So the idea that those methods convert, do typecasting, that should actually ring a bell. No matter what language you took in COP2513, there is always at some point a little session, a little lecture, half a lecture maybe on typecasting, okay? But this, so wrapper class, yeah, we talked about it. Abstract method. Each numeric wrapper class implement abstract method. These methods that I'm showing you are referred to as abstract method. These abstract methods are inherited from another class called number. So you get the feeling that number is much more general than integer or float or double, etc. So at this point, all I want to say real quick is, yes, we are going to start encountering like even more jargon because we are on the verge of starting module 3. Module 3 is where we are going to talk about inheritance. So when I say, it inherits from blah, 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 this is what I'm referring to. Module 5 is when we're going to wrap up the course and talk a little bit about interfaces, abstract class, and abstract method. Okay? So why did I not just, sweep those words under the rug? Because every time you look up something right now, okay, on Google or whatever, Stack Overflow, you are going to bump into those terminology. So I want you to have a heads up on, yes, those terms have a very specific meaning. No, you cannot just overlook them. They're really meaningful, actually, and we are going to cover them in the last 2 modules of this course. Okay? It's just that it's become impossible, especially with Java. It's become impossible for me, for example, in COP2513, to tell my student, oh, you don't remember how this little method works? Why don't you look up at the official Java documentation? I cannot even do that anymore. I've not been able to do that probably for the last 15 years. Why? Because at some point we introduced in Java a construct called generics. We're going to talk just a little bit about them in this class. It's a complicated topic, okay? But they introduced generics, and they said, well, generics are awesome. We're going to use them all over the JDK. So now every time you use a basic class from the JDK, you have a good probability that this class is going to use something that is a very advanced object-oriented programming concept. So again, beginner, I'm just doing my very first hello world. Okay, now I need to explain to you what generics are. To explain that, I need to explain what object-oriented programming is. I need to explain what inheritance is. It's just to do hello world, really. So that's peculiar to Java. Okay, so don't worry about it. Yes, we encountered that vocabulary. I'll always give you a warning like that, and then we will debunk it, demystify it, and explain it totally. So, what's the next block? The next block, and by the way, we have a toString method too. I should have maybe mentioned that before to move to the next block. We have a toString method in all of those wrapper class, so we can convert any sort of numerical object into a string representation, no problem. What else on the grocery list? Value of and parse int. So these are underlined. So these are like static method that you can access just directly with the name of the class. Okay. These are also conversion method. Okay, but they work the other way around. So you say, integer dot value of and a string that contains 2 and 3. And it's going to return to you an object, brand new object of class integer that contains the value 23. We've done that. Okay, we've gone from int to string and from string to int, but these are the methods that allow us to do that very conveniently. Okay, so value of, again, jargon, overloaded static method. So you know what a static method is. Overloaded, we mentioned it in passing one or twice. This is going to be the focus of our next module, okay? And I told you that those methods, value of, they return a reference to a newly created integer object. So you call integers.value of, so you call on the class, the value of method, you pass to it a string, and what it's going to do, it's going to act like a constructor, kinda. Because the outcome is going to be that it's going to create an object and return a reference to you. So a few lectures ago, 1 or 2 lectures ago, somebody was asking, can we have a constructor that's private? And I kind of said yes, but it's weird. This is why it's possible. There's nothing that stops you from having a static method, which means a method that can be called directly with the name of the class. You don't need to have an object of that class to call it, okay? Very important. I call it directly on the class, and that method is going to create an object of that class. It's called a factory method. These guys here are a form of factory method, okay? I call them, I give them a string, they create a new integer object, returns a reference to me. Bingo. I don't need a constructor. Well, yes, I do need a constructor to do other things. But my point is that there are some classes, not this one, but there are some classes where the constructors are going to be themselves hidden away, and all you are going to have to create object is static method like this one that are called factory method. So this is probably the only example of factory method we're going to really deal with in this class, but I wanted to draw your attention to that. What about the fact that we have two value of method? Well, it's because in addition to allowing me to convert, for example, 12.4 here as a string to a double object, or 12 as an int as a double object here, as an integer object, in addition to allowing me to do this, those methods also allow me to specify a radix, a base. So for example, if I have a number as a string that is written in hexadecimal, base 16, okay, I just specify, here's my string, and then I specify here 16. And automatically it's going to do the conversion for me so that it represents it in base 10 internally. Okay? So just convenient stuff. You don't need to memorize all this. You just need to know it exists, have heard of it one day. If you have a blank and you need to use it, your textbook is open during the quiz, your textbook is open during the exam, there's a reason. So that you may flip through the page and really quickly, check out the syntax. The last two that we have here, parseInt, it's kind of the same idea, except that those do not return a reference to an object of class integer. There are a few differences, but the most salient difference is these guys are going to return an int value, a primitive data type, instead of returning an integer. But the idea is the same. Give me a string that contains, 2 and 3, and I return to you the value 23. But this time just as an int, not an integer. All right. So this is the integer class. The double class is going to be very similar. All the numerical wrapper classes are going to be very similar to that. Now there is one more concept I need to add on top of the idea of wrapper class. It goes hand to hand with the idea of wrapper class. It's the concept of auto-boxing and auto-unboxing. Okay? So let me explain what we're dealing with here. What you have on your left in this box, in this rectangle here, is the declaration of what? The declaration of a reference variable named int array that is meant to actually contain a reference to an object of class array of integer. All right? And that object of class array of integer are somehow created here. Awesome. So what? Okay, I'm getting alerts here. Hold on. Robbery in the area of 51st Street and Fowler, remain alert. Avoid area. Emergency personnel responding. Okay, so we are in the classroom. We're fine. All right, let me acknowledge this and move on. Sorry about that, but it took over all my screen. All right, so what am I doing here? I'm trying to create an array. And it's an array of integers. So that means it's an array that contains references to object of class integer. Okay, just like an array of string, blah, blah, blah. So we've seen arrays of string. Now we're dealing with arrays of integer. I use that shorthand notation, the curly brace. When you initialize an array, when you declare an array and initialize it, that allows you to have pretty much Java creates the array using the new keyword and then populate it with values. But then the values that I put inside my array are, well, they're going to be object. It's an array of integer. So I use new integer of 2, new integer of 4, new integer of 3. So I have an array of size 3 elements of class integer. I create them on the fly like this, okay? I create 3 objects, put the reference in the array. Everything is shiny. Except that this is awful to write. As you get like larger arrays and you try to initialize them, all I want is values, very simple values, 2, 4, and 3. Again, the duality between I want to use primitive data types, but you force me to create you force me to create integer object because, whatever this data structure requires objects. So for all of those cases, Java is going to step in and say, that's fine. Just use the primitive data types. Okay? So write the code like it is on the right-hand side of the slide. You can still write this if you want. Java is not going to complain. You're doing it right. Okay? You're following all the rules. This is perfect. But this is what Java allows you to write instead so that you don't get carpal tunnel syndrome. Okay? Typing new integer all the time. And the concept of auto-boxing means that when Java finds a primitive data type somewhere, and it says, well, yes, I see the value 2 of type int here, but you are trying to shove this into an integer array. So your 2 should be an integer object. Every time Java finds a primitive data type in a situation where it should be replaced by its wrapper class instead, okay, or an object of the corresponding wrapper class, then it does it automatically. Auto-boxing. Your primitive value gets a nice box around it. It's an integer object, and now this is passed to the array so that we can initialize with it. Okay? So that's what auto-boxing is. And then, still to make things easy for us, we have auto-unboxing. So let's look at this example here at the bottom. I have an integer array that I create, using this syntax. So there is some auto-boxing going on here. Okay, all my primitive data type values are going to be put in wrapper objects. And then I do system.out.println, and I refer my array or int array, index 0, int array index 1, int array index 2. Well, I use the plus between them, the addition. The plus operator is not defined actually on the class integer. I don't know how to do a plus of one integer with another one using this operator. This is the operator for primitive data types. So what's going on here? Well, I need to take those objects, and what I need to do is I'm obviously trying to use a plus operator that works between int values. So I need to extract from those objects the int value. How do I do this? Well, I can go back here, and I can say, you know what? I'm going to call the method, where is it? Int value. There we go. So I'm going to call int value on int array index 0. I'm going to call int value on int array index 1. And I'm going to call int value on int array index 2. And then I'm going to add together those things. Okay? And then I'm going to display the result. Again, carpal tunnel syndrome, alert. Okay? There's a lot of typing there for not much. So every time Java realizes that you are using one of those wrapper class objects, okay, in a context that actually requires the presence of a primitive data type, it's going to automatically remove the box around the primitive data type. So remember, you took that int value, you put like a wrapper object around it. Now you need the int value. Automatically, it's extracted from the box without you having to write any code. Okay? There, you have a question or?
Yeah.
Oh, I thought you were just stretching. I'm so sorry. When I do that, just wave or do something like that. Okay?
So the plus operator in that output would just be like a composition operator?
No, it's still the plus operator that works. Very good question. It's still the plus operator that works on primitive data types. It's actually the plus operator that works on int value in this case. Okay, it's just that it's going to be fed the int values that are currently stored inside the object. So we don't have a special plus operator. We have a special way to extract the int values when they are inside object of class integer. Does that make sense?
So is that going to display one number or three different numbers?
One number. So you are going to, if we go step by step, okay, you are going to take int array index 0. You realize, crap, there's a plus, it's supposed to be a primitive data type, okay, I have an integer object instead. Unboxing. I go from the integer object to a primitive value, I convert, okay? So now I can apply the plus to it. Plus what? Int array index 1, same situation. Let me extract the int value. So now I have an int plus an int. The plus operator can be applied. I get a new int value, and I still have a plus int array index 2. Again, int array index 2 is unboxed. I have now two int value, add them together, and at the end, very good question, what do I get? One number or three number or what? One number. That is addition of the int values that were inside those three objects. Okay? There's a lot of stuff in Java where you have to know, what's going on, because it's done automatically for you. And when it works, you don't have to worry about it. You don't care about this. If it works, everything works in your code, you don't care about this. One day, you get an error, compilation error or execution error, and it's because some code you never wrote is inappropriate. And this is when you need to know about what Java is trying to do to quote-unquote help you, okay? So we cannot just ignore it. We still have to be aware of what's going on there. And why does auto-boxing and auto-unboxing matter? So I'm just going to give you the idea, and we're going to stop for today. The idea is, I already told you, we have in the JDK all those superb classes that work only with object, that are super reusable, that are implementing everything you're going to study in data structure and more. So you don't have to, but they work on objects. And I have primitive data type, which are efficient to work with. And I need to convert them back and forth. And so the conversion is already an overhead that we cannot escape, okay? But it's also an overhead for the programmer who has to constantly call the method int value to extract it, the programmer that has to constantly create a new object of class integer. So it's not that we stop doing those things. We still call the method int value when we want to extract an int from a wrapper object. We still create a new object of class integer when we want to box an int primitive data type. But at the very least, we alleviate, the syntax, so that some of that stuff gets done automatically by Java. That's auto-unboxing and automatic unboxing. All right. One more thing I lied. Sorry about that, but it's going to be super fast. I just want to mention this in passing, okay? There are two classes called big integer and big decimal. Big decimal meaning, big floating point number. These two classes, they are kind of like the wrapper class. You just look at the documentation, see what are all the available methods, and you're done pretty much. You don't have to really use them a lot. I'm just going to show you an example of how they are applicable. So we're going to jump directly to the code example here. You use them when you want to represent, like you probably guessed, big numbers. Okay? So we saw with the constant max value and min value that, yes, there is a range to what you can represent with an int. And most of the time it's going to be okay. If it's not okay, then you use a long. It's double the size of a int. I mean, it's not double the size. It's double the number of bits, which is exponentially bigger. Okay? But then the long is not good enough. Where do you go? You're going to call. You are going to go to big integer. And it's a little bit more awkward because now you can have, if I remember correctly, you can have an integer number that has an arbitrary number of digits. So you can store some very, very large number like this, okay? But the problem is that now you're using an object, and there is no primitive data type equivalent. We cannot have an over notation that's better. So here's me creating a big number, okay? And I specify it as a string because I don't have a choice. There's no notation in Java that would carry that many digits for an int or for a long. So I have to really specify it as a string. My big integer could be something ridiculous like 2, in which case you are entitled to ask, what are you doing here? But generally we use it for big numbers like that. And then every single operation has its own method. You want to multiply, there's a method. You want to add, there's a method. You want to divide, there is a method, and so on and so forth, okay? So it's just to remind you that when you have objects, even if for those objects may represent, numerical values, for example, like int and stuff like that, you cannot apply necessarily the default operators, the plus, the minus, the divided, the star for multiplication, okay? The same way that we saw, actually, based on your question, we saw that we had to convert to auto-unbox, to get that system.out.println to work. Well, same thing here. The plus would not work. We would have to do some unboxing, except that, we cannot unbox to anything because there's no corresponding primitive data type anymore. A big integer is a thing on its own. There's no equivalent in the primitive data type word, okay? So keep an eye on those things. Take a look at the reading assignment for this. It's quick, just read it 5 minutes, know what's there. We're not going to super emphasize this in this class, but I want you to at least know that it exists, okay? So that if one day you have a problem, you exceed the capacity of a long, let's say, you know that it's time to do 5-10 minutes of reading and finally learn how to use those classes, okay? All right, we're going to wrap up for today. Thank you so much. And if you have some quick question, please hang around at the end of the class.